Students, let us solve this Irodov problem 1.21. This is a very simple question. At the moment t equal to 0, a particle leaves the origin. What it means? At t equal to 0, x equal to 0. Moves in the positive direction of the x-axis. Particle is moving in this direction. Okay. Its velocity varies with time as vector v equal to v naught vector into 1 minus t by tau. Okay, where v naught vector is the initial velocity vector. So particle have initial velocity vector. So this is initial velocity v naught. Let me call this direction as direction of v naught. Okay, whose modulus is equal to v naught. It means that the magnitude of this velocity is 10 centimeter per second, and given that this number tau is 5. Find the x coordinate of the particle at moment of time 6 second, 10 second and 20 second. So we have to calculate the x coordinate of particle at different time. How I can proceed that? This is the velocity. This is the equation of velocity is given. If I differentiate it with time, it will give the equation of acceleration. So this is a constant number v naught, and the differentiation of 1 is 0 and differentiation of t is 1. So this is minus 1 by tau. So the acceleration is minus v naught vector divided by tau. Oh, this is also constant, this is also constant. It means that acceleration is constant and in the opposite direction of initial velocity. So the particle acceleration is in this direction. Yes. And what is the magnitude of this acceleration? V naught by tau. V naught by tau. And it is equal to V naught is 10 and tau is 5. So 2 centimeter per second square. Okay, what is the initial velocity? Initial speed? Magnitude of initial speed is 10 centimeter per second. So this is a very known question in which the velocity and acceleration are in opposite direction. So what kind of motion it will follow? It will go further away, stop at an instant and then come back. So this is the question. Now we can calculate the moment when its velocity becomes 0. So the stopping time, this time is called a stopping time, and the formula of a stopping time is initial velocity u divided by acceleration a. So initial velocity is 10 and acceleration is 2. So a stopping time is 5 seconds. So a stopping time is 5 seconds. So this time is 5 seconds. Now this particle will again come to this point at time t equal to 10 seconds. 5 seconds to go forward and 5 seconds to go backward. Now when this particle will reach at this point, the velocity will be in this direction and again of magnitude 10 centimeter per second. Can we calculate this distance? Yes, this distance is called stopping distance, and the formula of a stopping distance is u square divided by 2 into acceleration. What is the u? U is 10. So 10 square 100 and 2 into acceleration is 2. 2 into 2 4. So it is 25 centimeter. So this distance is 25 centimeter. And this again distance is 25 centimeter. Okay. So these are the common things we can calculate when these data are given. So what is the question? We have to calculate x when time is 6 seconds. How to calculate x? There is a well-known formula, s equal to ut plus half a t square. So what is u? 10. What is the time? 6. Minus, because acceleration is minus, half acceleration is 2 into t square. 6 square 36. So this is 60 minus 36. So this is 424. So this distance is 24 centimeter. So at times t equal to 6 second, the x coordinate is 24 centimeter. Similarly, for 10 second, we put this t as 10. So x at 10 second is 10 into 10 minus 1 by 2 into 2 into 10 square. So this is 0. So this is 0. Now we already know that 5 second it had to go forward and 5 second it had to go backward. So at 10 second its again position is this, and this is x equal to 0. Now our calculation also show that at t equal to 10 second x is 0. What is the value at t equal to 20 second? So x equal to 10 into 20 minus half a into t square. 20 square 400. So it is 200 minus 400. So it is minus 200. And this number is in centimeter. So its position is minus 200 centimeter. Now if you check the book of Irodov, the answer for this 20 second is written as minus 4 meter, which is wrong. You can check this number as this number is not minus 4 meter, this number is minus 2 meter, and the correct answer is minus 200 centimeter. So this is the correct answer. So at x equal to 6 second, answer is 24 centimeter. At time t equal to 6 second, x is 24 centimeter. At time 10 second, answer is 0 centimeter. And time 20 second, answer is minus 200 centimeter. Now there are two other parts also in the question. The moment of time when the particle is at the distance 10 centimeter from the origin. So 10 centimeter from the origin, this is the origin. So 10 centimeter means at this position. At this position, particle will be at two times. One during going forward direction and one during going backward direction. So we have to calculate both time t1 and t2. How we can calculate? So the same formula we can apply, s equal to ut plus half at square. So the formula is s equal to ut plus half a t square. Now there is a small problem. Distance 10 centimeter from the origin, it does not mean that distance is 10 centimeter. From origin, distance 10 centimeter means this distance 10 centimeter. Now this distance is 10 centimeter, and again there will be a distance of 10 centimeter here. This distance is again 10 centimeter. So there are total 3 times. It is not written at position 10 centimeter. It is written at distance. Distance means 10 centimeter either can be in this direction and 10 centimeter either can be in this direction. And at this location, there are 2 times and 1 time for this position. So the answer is 3 times. Okay, now first for this position, s is plus 10, u is 10 into t minus 1 by 2 into 2 into t square. So 10 equal to 10t minus t square. So t square minus 10t plus 10 equal to 0. Now this is a quadratic equation. So t equal to minus b, 10 plus minus under root b square, 100 minus 4 into a into c divided by 2 into a. So it come out 10 plus minus 100 minus 40 root 60 divided by 2. So one time is 10 plus root 60 divided by 2 and other time is 10 minus root 60 divided by 2. So these are the two times. This time is T1, this time is T2 because this is less, and this time is T1. Now I have to calculate this time. How to calculate this time? When the particle at this position, the S is minus 10. So for third time, I have to put instead of plus 10, minus 10. When the particle is at this position, this displacement is called minus 10. Okay. Now the equation is minus 10 equal to 10t minus t square. It means that t square minus 10t minus 10 equal to 0. So t equal to minus b plus minus under root b square minus 4ac. Minus and this minus becomes plus 4 into a into c divided by 2. So the third time will come out 10 plus minus under root 140 divided by 2. Now when we take minus sign, this number is more than 10, so we cannot take minus sign. So there is only one time and it is equal to 10 plus under root 140 divided by 2. So I got all three times T1, T2 and T3. So this is the procedure. Now in the part C, the distance is covered by the particle during the first 4 seconds and 8 seconds. So during first 4 seconds, now this is the t equal to 4 and 8 seconds. 5, this will be 6, this will be 7 and this will be 8. So this time is 8 seconds. So first I calculate this part. In this case, distance and displacement both are equal. In this case, distance and displacement both are equal. So how we can calculate that? We use the direct formula of S. So S equal to ut plus half a t square. What is the value of u? 10. What is the time? 4 minus half 2 into 4 square. So this is 40 minus 4 square 16. So it is 424 centimeter. So this length is 24 centimeter. Okay. Now at time t equal to 8, when we put time t 8 in this formula, what is the value of S? So 10 into 8 minus 1 by 2 into 2 into 8 square. So this is 80 minus 64. So this is 16 centimeter. So this is displacement, not distance. It means this is the value of displacement. So this is 16 centimeter. Okay. Now at time t equal to 4 seconds, this is the value of distance. But at time t equal to 8 seconds, this is not the value of distance. Distance is this path length plus this length. So what is this? Now we already calculated this length. This is the stopping distance and it is equal to u square divided by 2 into a. So this is 25 centimeter. Now this is 25, this is 25. So total is 50. And we have to count only this length and this length, so minus 16. Minus 16. So 420 and 30. So at a time t equal to 8 second, the distance covered is 34 centimeter. So this is the answer. Now draw the approximate plot of displacement time graph. So this is very simple. What is the displacement time graph? This is the time. At t equal to 0, particle is at origin. At t equal to 5 second, particle is at a 25 centimeter distance from the origin. And at t equal to 10 second, particle is again at the origin. Okay, yes. Now acceleration is constant. It means the displacement time graph is a parabola. So from this point to this point, either parabola can be this or this. Acceleration is negative means downward parabola. So this is the correct curve for time t equal to 0 to 5 second. Again, from this point to this point, curve is again parabola. Now there are two possibilities. Either the parabola should be this or either should be parabola like that. Now acceleration is again minus. Acceleration is always minus. So again the curve is downward parabola. So from 5 to 10 seconds, this curve will be downward parabola and the curve will remain most like this. So this is the approximate plot of displacement versus time.